Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to talk about some strategies you can use to help find and fix flaky tests. First off, what's a flaky test? A flaky test is a test that will change between passing and failing without any code changes. A simple example is a test that you run 100 times in a row without changing anything. If it sometimes passes and sometimes fails, it's a flaky test. Flaky tests can be extremely frustrating to deal with. When a flaky test fails, you'll spend time trying to figure out if it's just a flaky test or if it's related to whatever change you recently made. If there are enough flaky tests, you might start to defaulting to automatically retrying flaky tests and only investigate if they fail consistently. In any case, flaky tests will slow you down one way or another. So ideally, we fix flaky tests just like regular broken tests when they appear. But this is hard because it's hard to figure out what's wrong with a flaky test. It can be hard to fix reproducible bugs, so what can we do against bugs that aren't reliably reproducible? While there are many different places flaky issues can get introduced, today I'm going to focus on issues that we've directly created in our own code, as opposed to being an issue with some third-party library, hardware, or faulty drivers. These issues can absolutely cause flaky tests, but generally speaking, most of the flaky tests I've seen and worked on have been in code that my team has been directly responsible for. We made the flaky test. This is also generally the spot you'll want to start looking at first when debugging, because it's easier to investigate these locations and then prove or disprove if the flakiness is happening there or somewhere else. Stepping back and thinking about computers broadly, generally speaking, they are really, really good at doing exactly what we tell them to do. So if we've got a flaky test and we assume the computer is doing exactly what we are telling it to do, that suggests that maybe though we aren't changing our code, we're somehow telling the computer to do something different for each test run. But how could that be? I've got 3 examples today that will show how this could happen. We can accidentally be changing global state. We could be dealing with threads that aren't synchronizing themselves properly. Or we could be adding randomness ourselves. Let's jump over to our first example. So we've got a class here called account database. It's pretty simple. It takes in pairs of accounts and related phone numbers, and then they can later be queried to get the phone number for a given account. While this could be done within a regular Python dictionary, for this example, it's using a database to store this information, which kind of makes sense in real life. Now, since it can be a little slow to query databases, at some point we added a nice little cache variable. So in get account phone number, if the value is already in the cache, we can just return it quickly. And if it's not, then we will execute a query on the database, and we will save the value in the cache. So, like I said, in the future, if we call it, we can just return right away and be faster. Nice little advantage. And down below, we've got 2 simple tests. Get account phone number, make sure if I put in my name and my fake number, I can get my fake number from my name. And that if I start a new database and I put in my name without giving the number, I can't find it. So, all right, that seems good. Let's run the tests. Oops. Well, the second test fails. For some reason, we get a number for account Chris. If we look, they are both creating new account databases. They're both creating them in memory. So how is this happening here? So I did say that normally you don't change code for flaky tests, but to avoid running this on the command line, I will slightly change some code down here. So we will run just our no account test. And it works. And no matter how many times I run it, it's going to work. And if I run the full test suite, no matter how many times I run it, it also works. So while this doesn't look flaky here, I have seen issues like this before that are flaky if the tests run in a different order. Since our test is passing when it's run by itself, it probably would pass if it was the first test to run. In this situation, it's the second test to run, and that seems to be why it's failing. So if we were running, these on different machines or sharding them out or something, there could be some shuffling. So this, though, should be a big hint for trying to figure out what's happening here. The order of execution seems to matter. So if you've got a test that fails when it runs with other tests at some frequency, but always passes when it runs by itself, you've probably got an issue where global state is getting mixed up. And it's probably not the failing test that is causing the issue, it's just the one that's breaking because of it. The failing test is supposed to be starting at some state A. For our example here, it's assuming that it's starting at a state where there doesn't exist a phone number for Chris. But actually some other test is running first, and it's causing this test to actually start in a state A alpha instead. For example, in this one, it's somehow that Chris as a phone number does exist. So we've got an easy hint here, because it's not too big a file, luckily, that the phone number we're getting here is the phone number in my other test. So we can probably verify this by just changing the phone number in the other test and seeing if it gets propagated. It does. So somehow this value is making it into this test. But they're both creating their own databases in memory. So how is this happening? Well, since I wrote this example, and it doesn't have much in it, and it's fairly simple, well, there's only one global variable, cache. So when the test suite runs, test get account phone number, when it adds the phone number to the database, when it fetches it, it then saves it to the cache. And then when the next test is created, we didn't clear cache, so it still is in the cache. So when we call get account phone number, hey, that number for Chris, it exists in cache, so we return it. And that is why it fails, because the value is in the cache. Now, there are two suboptimal ways we could fix this issue. We could update this test, look for a different user. We could say Chris 2, and now it passes. But we didn't actually fix it here. We just changed it such that it's using a different name. We still could have cache pollution between the two of them. The other option, and we saw when we ran just the one test, is we could try and change the order the tests run in. If no account runs first, then everything should be fine. And while both of these do fix things in the sense that our tests pass, they don't fix the underlying issue. So we could have issues related to this again. So the better solution here is actually relatively straightforward. We should modify cache so it doesn't leak data between tests. One way to do that is we could have each test clear the cache during its setup. So as part of its prep or teardown, they could make sure that cache is empty. I'm not a huge fan of this though, because this requires the test to be aware of cache and make sure that they properly are clearing cache. Instead, what I think actually makes more sense is don't make cache a global variable. Instead, let's add cache into the account database. And then it will get properly created when we create a new account database, and it'll get deleted when we delete one. It'll have the same scope of this, and we won't have to worry about things going up to a global level. And if we run the tests, hey, it passes. It passes every time now. So we've removed the leak. So that is one thing to look out for with flaky tests: accidentally leaking data or state with global variables. So if you've got a flaky test, see if it's reading or writing to global state. That could be introducing issues. Try and reduce those if you could. All right, on to example 2. So for example 2, I've got a code snippet here that is heavily inspired by an issue I ran into a few months ago with some testing code. I've also added a few sleep calls in the code to make the flakiness easier to control for the purposes of this example. So we've got a class called GameEngine. All it does right now is allow itself to be initialized with initialize async, and allow itself to be queried whether the initialization has finished or not. Well, completed. Now, there could be network calls or disk reads in this initialization, so the code actually spins up another thread here, setup thread, to handle the initialization work. This can make a lot of sense if we don't need the engine to be ready right away, and we also need to do some code parallel. So if we actually look at the initialization code, all it does right now is call this validate engine license. We'll pretend it's third-party code, but I've modified it to just randomly take up to 2 seconds. And if we go down to our test, we've just got a simple test here. We just create the engine, we trigger it to initialize, and we make sure it's initialized after sleeping for a bit. And if we run, it works. But it's slow because we're sleeping for 3 seconds. If we change this to 0, we passed once, we failed once, we fail, we pass. Ooh, yeah, we get a lot of flakiness there. If we change it to 1, okay, we passed, we failed. All right, yeah, so with 3, we're kind of consistently passing here because behind the scenes we know this will only take up to 2 seconds. But we also saw that sometimes it passed when we didn't sleep or only slept a second. So do we really need this 3-second sleep? So this is something that I've seen many times before. There is a strange failure, but by adding a sleep call, we can get the tests to pass. It slows things down, which isn't great, but we got the test passing. And I guess a passing test is better than a flaky test, but it's still pretty bad as sleep calls are basically just hiding the issue. If, we were to change this and this could take up to 5 seconds, then we're going to need to adjust our sleep because past that time, is it going to pass this next time? It does. Is it going to pass a third time? Oh, it doesn't. Yeah, so now we'd have to go in and figure out okay, how long should we sleep to here? That's not great. And then later, what happens if we say, well, I gotta wait 6 seconds here? What happens if they really improved their code and this only takes up to 1 second? No one's going to go in and test all of the sleeps, so we've got a bunch of sleep time that we don't really need. The solution here isn't to sleep, but to try and find a signal or trigger we can use instead and wait on that. If we look at our code here, the problem is around the initialized variable. We because we know this always returns true, the problem is that we're trying to read this before initialize has actually set it. So if we look at it, it's getting set by this as the last thing that initialize is doing. So we don't want this function to return until this function has a chance to terminate and set the right value. Luckily, this is really easy to do for this snippet. Since initialize is the only thing that's run by this setup thread, we can just wait to see if start thread is done running or not. Since when it's done running, we know that self.initialized will have the right value. And if it's still running, we can just wait for that. And luckily, this is easy to do with Python. So we can just go here and just add self.startupThread.join. So now if the thread is done, this is basically no operation. And if it's not done, we'll wait here until it's done. So now with that, we can take out our sleep and yeah, our test is passing. And I'd also point out that you can look at the time it takes. Sometimes it takes a second, and sometimes it takes 80 milliseconds. That's because it's only waiting as long as it needs to be. So it can stop as soon as it needs to. So if you have a flaky failure that seems to be fixable via adding a sleep in certain spots, it's probably a sign that there's some communication missing between maybe threads or processes. Try and figure out what is being examined. Is there a variable that's being looked at? Is there a hardware device that's being queried that's not ready yet? And try and figure out if there's a better way to communicate when it's ready to be interacted with, instead of just waiting and hoping that it'll be ready to interact with. All right, let's jump over to the final example. All right, so we'll end with the smallest example here. User pools just lets users get added to it, and then you can call get random username, and it randomly picks a user and gives you their name. And we've got a very simple test here that adds a handful of users and then just prints a handful of names. And if we run it, yeah, all right, we got 4 names, cool, and we got a crash. And it printed off 1 name. Now it printed 2 names and a crash. Okay. Now, this is because there was a small mistake writing the test. I accidentally added a none user. So whenever we randomly pick that user, none.name, it has no attribute, so that doesn't work. So we can fix this by just removing this line. And now I can run this many, many times, and it's fine. That's good. But what happens if I accidentally added this back in? The flaky test would be back. So in addition to removing the bad data, is there something we could do here to make tests like this less likely to be flaky? Well, part of the problem here is that we've got randomness in this test by design. So the test is going to be random from run to run. The first thing is, if we don't actually need the username to be random, we maybe want the oldest or the newest, we could change that and get rid of the randomness. But what if we actually want the randomness? Can we handle that? Yeah. So one option is that you could set a random seed at the beginning of our tests when they're getting set up. In Python, you can do this with a simple little thing called random.seed0. So with this, instead of using a actually random, well, semi-random seed, every time this test is run, it's going to set the random seed to 0. So this test will operate the same way every time. And if I run it, we're now seeing that, yep, every time it's Eve, Jim, and then the invalid data. So with that, we still would want to remove our none, but at least here we know we'd be getting consistent expected values. We could even, if you remove the none, you could even say, okay, actually instead of just printing, I should say that, yeah, the first one will be Steph, then Jim, then Steph. You can do that now. We could also modify get random username to take in a random picker instead of using the built-in Python random stuff. And in tests, we can default that to always taking the first one or always taking the last one. But I think that's overkill for this example. I hope that this shows that if you have a test where you have intentionally inserted some randomness, there's a good chance that that could cause flakiness. So maybe see if you don't need that randomness at all, take it out. Or if you do need it, see if, at least for tests, you can sort of remove the randomness. That's all I've got for today. Hopefully this gave you some ideas on how to better deal with flaky tests in the future. If you have any tips or secrets on how you deal with flaky tests, please leave a comment down below and share with others. If you enjoyed this video, please consider hitting the like button and subscribing. If you have any other comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.